But before I will ask you the fundamental question, do you have any questions? I feel obliged to answer some question I got via email. Thank you, Blanca, for your very good question. Things connected with the so-called final presentation, and I got such a question. Will we finally make a final presentation for the course? Well, and we are talking that I have some ideas what the presentation should be, and I feel big to answer this question. But the answer is really there is no good answer. Nobody knows what will happen in January. Whether the classes will be held online, like today's, or we will held in a stationary or traditional mode. Let's look into the calendar. Today is the 2nd December, and our classes will be on the 9th, 16th, and this is change in calendar, 20th of December, and 4th of December, 13th, 20th, and 27th. So, if we choose the option for YouGives presentation, I think that last 3 classes will be devoted to presentations. Or there is also, you can decide, regular lectures and 27th of, sorry for a typo, January, the quiz. Well, I do prefer presentation, but well, I have to take into account some which is unpredictable. Maybe you will be very difficult to meet in groups to prepare the presentation. Well, of course, there still is ability to meet using online tools. You can start short meetings using Zoom or Google Meet or whatever other tool you would like to use. So the fundamental question is: do you prefer quiz or you prefer presentations?
Presentation.
So, oh, sorry, I don't share my screen, so I will, sorry, go back to the question. And to the timing. And well, there's one answer, presentations. Okay, so let's try to make launch a poll. Please take into account that there's only 19% present, so I will relaunch the poll near the end of the lecture to check if somebody will be late.
Good morning.
Fifteen persons on 20 answer the quiz. So let's end the poll, and the result is 2 persons quiz, 11 presentation. I have no opinion, 2 persons. I will relaunch the quiz at the end of the lecture. So go back to this short presentation and some details. There is 31 students in the group. This gives us 10 presentation groups. In average, 3 persons each group. So when we start on the 13th of January, 3 classes, each class 90 minutes, this gives us 270 minutes. So 20 to 25 minutes for each group, including short discussion and even some time for something strange which can happen. You choose the dates of the presentation yourself, but I can start the reservation system. And you will reserve the time. It's up to you. Please tell me if you really want such a reservation system, or you will send me an email with topic and persons involved in the presentation and such things. Presentation topics. Almost everything connected with internet, computers, information technology, mobile life and education, modern digital technologies. Absolutely everything which is interested for you and is somehow connected to new technologies, digital technologies, will be also interested for me, and I hope will also be interested for your colleagues. But when in doubt, ask me simply by email. In most cases, I'm talking from, well, few years, I can accept almost everything. Okay. Do you have any questions with presentations? What about reservation system? On my web page, you can choose the term and reserve them. No idea. Okay. So probably I can start the regular lecture. Ways of presenting algorithms. You know what the algorithm is, so it's quite easy. This slide is somehow connected, this illustration on the title slide is somehow connected with the final slide of a presentation. If we have time to discuss this problem, we will back to this picture. How to write down algorithms you developed. The simplest way is to use natural language. Simple sentences in imperative mood. Do this, do this, do this. If, do this, else, do that, something like this. I will tell you in a moment, showing flowcharts as another way of describing, noting algorithms, decision tables, a little bit later, pseudocode. I will not focus on the pseudocode or programming languages because it's not a main topic of our lecture, but you have to know that the algorithm written in programming language is the, well, final and the best way of describing algorithm because it can be directly read by the computer and execute by the computer. So it's the best way of noting and presenting algorithm. Flowchart. It's also called block diagram. Type of diagram that represents algorithm or process. Well, when we tell that we have to, well, at the end, got some result. And we're starting from some initial data. There is a, well, sometimes short, sometimes long path of task which has to be done to obtain the result. And this is kind of a flowchart, block diagram. We are connecting blocks with arrows. So there is only one way to go. But here we have to make a decision. And at the end, we will got the result. And this is called flow chart. And we will use various kinds of block, various shapes of blocks. And well, looking at such a block gives us the idea how the algorithm works. So there are two main reasons to write down the idea of algorithm or analyze of algorithm. Introduced in early 20s of the 20th century. So, you know, it's quite old idea. Von Neumann used to use such a flow charts during programming. Symbols used in the flow charts, there are most common symbols, but you should know that there is quite a lot of different standards. This I taken from the military standard, because, well, military, as you know, like to standardize everything they take into their hands. And this is the most common set of symbols. On the other hand, we will use only some of them, probably this one, probably this one, definitely this, and this during my class. The other are not so important, but well, okay. Sometimes they are in use. Well, when I was studying, I was in your age, approximately. You can buy in shop such a flowchart template. Looks like this. not exactly like this. This is nice because it has explanation of each block used on the template. There are also special military standard template mentioning the number of the military standard somewhere in the side of it, having also a ruler or something like this. Nice device, but nobody uses this today. Rather trying to use some specialized tools, electronic specialized. So let's start describing the symbols. Terminator symbol written like this, but sometimes drawing as an ellipse. Wow. Something like this also can be. Signals the start or end of a process. It is usually contains inside such a word as a start or begin, at the beginning, stop, and at the end, or something like this. Data symbol, also called input-output, indicates input and output from a process. To note that at that point you should prepare data to put into the process, or you will obtain some results at that moment. The most important symbol, process symbol, sometimes it will be something very simple like increase z by 1, add 1 to z, or something like this. But sometimes it will contain more complicated task, for example, sort the data. But in this case, we will use something like this with 2 additional lines in here. Predefined process symbol, it means that this is a little bit more complicated process which will need its own block diagram. Sometimes it will be called as a subroutine. Most important symbol, decision, which allows to make decision, and you know there are only 2 exits from this block. Moment. This is one way. Other way is the third exit. This cannot be. I don't know, because there's the computer. So let's change the idea about the decision. Erase it here. Yes. No. So the question will be x and 0 greater than, equal, less than 0. Compare x with 0, and there are 3 results. Something like this. Something simple like this. And connector, if we need to connect to another place in very complicated block diagram, we will use something like this. For example, something new. Look, there's some kind of a complicated block diagram. And we have to connect that point with that point. I can choose and draw the line like this, or that sometimes is much better. We'll use something like this. A, go to A and put A in here. Sorry, this is not A. It doesn't look like an A. Oh, okay. Go here. Less lines and easier to read them diagram. There must be inside some kind of a symbol, for example, A, B, C, and if the diagram is much more complicated, we'll use something like this, 4.32 B2 or something like this. And sometimes there is like in a, sorry, this, sometimes we are dividing the flow chart like a spreadsheet, B, C, D, E, 1, 2, 3, 4, divided rows and columns. So this symbol is in, you can see D2. So I can write here instead of writing A, D2. It's easier to find the symbol on this kind of a spreadsheet. Let's start with some simple example, selecting the highest person in the room. In natural language, the algorithm can look like this. Select any person from the audience. Think of it as the highest and place near the door. Next, we are checking if there are any people left in the room. If so, go to step 5. If not, the highest person is one standing near the door. When there is only one person in a classroom, is the simple highest one, yes? And of the algorithm at that point. And step 5 in here, take another person from the room. Well, we know that there are any other people in the room because we have checked this in step 2. Take another person from the room. Compare it with one standing near the door. Is it higher? The new one is higher or not? If not, go to step 2. Check if there are any other people left in the room. And if so, take another person from the room. If not, end algorithm. But if the person taken from the class is higher than one standing near the door, we are replace the person standing near the door and go to step 2. And this is block diagram. Start. Select any person, first person from the class. Is anybody left? If no, the highest person is one standing near the door. Stop. Is anybody left? Yes. Take the next person. Is it higher than this standing near the door? If no, we are starting from the beginning, but if yes, we are replacing the person standing near the door by the new one. And we got a very simple block diagram of algorithm of finding the highest person. This is block diagram of algorithm mentioned in one of the previous lectures about computing sum of salaries. Start, point to the first salary and note 0 on the side, add salary pointed to noted number, Are we at the end of list? No. Point to the next salary. At the end of the list, yes. Output noted number and stop. Well, as you can see, probably these two algorithms are very similar in his idea. Euclidean algorithm, 3 steps: find the remainder, the first step, checking if the remainder is equal to 0, the second step, and simplifying, the third step. And look, once again, very simple: start, find the remainder. Is it 0? Yes, stop. Display the value. Not, simplify and go to the beginning, find the remainder once again. Idea, very simple, very nice, and really very often helps to build algorithm. And even if you are creator of algorithm, better understand how it works and better understand where the errors are introduced. In 50s, trying to describe some complicated, mainly business processes, scientists developed decision tables. It's an alternative to the flowchart, especially useful if there is quite a lot of decision to make. Think about a situation when we are trying to describe our process and we have to make one decision and another one decision and decision in here. There is no action, but we are taking only decision. The situation is typical for quite a lot of business processes. And such an algorithm became very complicated. And you know, oh, in here, I have to go to that point. So we have crossing lines or quite a lot of, such things. This is very difficult to understand, very difficult to read. So the decision table is much better. I will tell you how a decision table can look like. Work best with complex decision problems is absolutely useless in computational problems. Today is a little forgotten, but well, still used. The structure idea came from the 50s, as mentioned. The structure is very simple. There are conditions and the alternatives and actions. Written that way, sometimes another transpositive way. Each decision corresponds to a kind of a variable whose possible values are listed among the condition alternatives. Each action is a procedure which has to be performed to solve the problem. Look, this is a very simple example about the printer. And first, at the upper part of the table is conditions. 3 specific conditions. Printer does not print. A red light is flashing. Yes, no. Printer does not print. Yes, no. Printer is unrecognized by an operating system. Yes, no. And some action which has to be taken to solve the problem. Printer does not print. Yes. A red light is flashing. Yes. Printer is unrecognized. I'm talking about the first row. Yes. Check printer computer cable. Ensure that the printer software is installed. Sometimes check replace ink. Printer does not print, but red light is flashing, but the printer is recognized by operating system. So there is probably a connection between printer and computer. So we have to check for some specific errors. There is no ink, or there's something which is called paper jam. Printer does not print, yes. Red light is flashing, no. But printer is unrecognized. Once again, we have to check if printer is connected to the main. Check printer computer cable and install or check if the software is installed. And at the end, you have printer does not print, no, prints. Red light is flashing, no. It's unrecognized, no, it's recognized by system. There's nothing to do. And it's very simplistic even situation, but when you check them, all older versions of printed documentation, you will find something like this, telling what to do in some specific situation. Another example of decision table is such kind of table allowing us easing to make decision about buying a car. They can be free by free table, 9 different situations. Price of the presented car is really very high, excessive. Price is okay, and price is somehow underestimated. And on the other hand, we have the car meets all our requirements. The car does not meet all the requirements, but the condition, the equipment are acceptable. And the third one, the car does not meet the requirements. So the car is nice, but the price is really high. Start discussion with the seller again. If you do not succeed, came back the next day and bargain again. Buy even if you cannot reduce the price, because it's very good car, in good condition, with good equipment. Well, a little bit overpriced, but there's not a problem of money, but it's a problem of buying something worth this money. When the price is okay and car meets all our requirements, bargain, buy it, whatever the result of negotiations. Underestimated price, simply buy and use it. The car does not meet all our requirements, right here, but price is too high, resign. Not only is expensive, but also does not meet our requirements. Price is okay, but the car still does not fulfill our requirements. So starting discussion with the seller and buying the car if the price is reduced. When the price is a little bit lower, then medium, bargain, buy regardless of the result of negotiations. Excessive price and car does not meet our requirements, we resign. Price okay, but car still does not meet our requirements, we resign. But the price looks good, so we can try to discuss about the extras. Buy if the price of the extras is reasonable, or changing the value of car, buying some extra. Well, don't use this in real situation, but there's some theoretical description of the problem. And at the end, probably something not at the end, something very simple. Dressing a code, looking through the window and checking it's raining, looking at the thermometer if the temperature is high or low, cold or hot, yeah. And when there is raining and it's cold, we have to dress warm raincoat. There's a raining but not cold, simply raincoat. Not raining and it's cold, warm coat. And there also should be the fourth situation when there's not raining and not cold, so there's no need to use any kind of a coat. Look here, we have two conditions. Simple answer yes, no. In common, there will be four situations. Here, here we have three conditions. Answer yes, no. In common, there is 8 different situations. 1, 2, 3, 4, 5, 3. 1, 2, 3, 4, 5, 6, 7, 8. And the last example, something which can be called internet shop or solution called today business to business, B2B. It's a decision table describing the activities related to adoption and execution of the contract. The shop policy is that company serves registered customers only. And company supplies goods from the list of goods only. So unregistered client will not be served by a firm. And this is typical situation when two firms make an agreement to automatically buy some goods. For example, printer paper, printer ink, and such things. And once again, we have this very simplified situation. We have 3 conditions. Item on the list, yes, no. Customer registered, yes, no. And sufficient supply of goods. Can we sell this or have to wait some for making new reserve of storage? Sufficient supply of goods, yes, no. And there should be 8 different situations, but because looking at the very special situation, item on the list is not very important, doesn't care when customer is not registered. And this reduces us some 2 different situations that should be written item on the list, yes, written on the list, no, but in each situation, the result will be the same, reject the transaction. And there's also not important if we have sufficient supply of goods. There also should be yes, no, doesn't care, because this condition is most important. Exactly the same in this situation. Item on the list, no, it's not important if customer is registered or no. We have, well, cannot discuss the problem with sufficient supply of goods when the item is not on our list. There is no such a good. This allows us to reduce the number of conditions which have to be taken into account. So, item on the list, customer registered, yes. Sufficient supply of goods, yes. Book the item, log the transaction, and deliver the item. to the customer. Item on the list? No, reject the transaction. Customer registered? No, reject the transaction. And item on the list? Yes, customer registered? Yes, but we don't have sufficient supply of good. So we have to save the item for the list to realize. And this transaction should wait some time for and well, one of my colleagues wrote some quite complicated program and try to build a block diagram, but the program is something very similar to artificial intelligence or something like this. Very complicated rules, and we cannot end the task because he cannot write down the algorithm, which was in his head only. After a short discussion, I take from my bookshelf book describing the decision tables, borrow this book to my colleague, and sometimes later he taught me that, well, after reading this book, he can write down the algorithm, and finally the quite complicated program was created. So there is something in this, but in those days no one looks to draw block diagram or try to write down complicated decision tables. Programmers simply sit down in front of the screen and start to use the keyboards and write the code directly from their head, which is not very good decision. Programming languages. Well, this is a flow chart of Euclidean algorithm. And if you remember, I present you this algorithm written in Google Blockly, and please, you can try to use this Google Blockly as an example of some, well, somehow simple but still programming language. There's not much space on a workspace, so you cannot use Blockly for very complicated tasks, but this is real programming language, and the block diagram, this block diagram can be easily translated into other computing languages like Python, Lua, or Dart, or JavaScript. So this is the best way of programming language, is the best way of describing an algorithm, but well, this is this block converted into JavaScript. And please look at these programs, which are very similar. Look, in here we have while r is not equal to 0. This is not, this is equal, not equal to 0. In here we have exactly the same, but here this condition is in parentheses, but in here is not. Here we starting the block of instructions, this, and this, which are executed while r is not equal to 0, and we are using the curly braces. And in here we are using colon, and the code of this block of instruction is a little bit indented. This is the computing the remainder. Look in here, the same instruction. Here are semicolons at the end, but here not very important. Another programming language, PHP, while once again, the variables I named quite different with the $sign, but you know, not big difference. Curly braces once again, semicolons, reminder, Lua, once again, while. Here, the very small difference, there's exclamation for not, and here is tilde for not equal to 0. The rest looks exactly the same, but instead of curly braces, we are using do and. And once again, Dart, exactly the same. Knowing one computer programming language allows you to understand, of course, simple programs in most of computer programming languages. An algorithm, do you have any questions at that point? Sorry, probably some package for me or something like this. Sorry. Let's make sure. Usman. Exactly. The Christmas is coming. Well, there are 25 person now, so let's use this time to relaunch the poll. Please answer the questions once again. Okay, I really understand the situation. There's much more participants than the beginning, but less active participants than on the beginning. So let's end the poll. The results are somehow the same. Let's go back to algorithm. The algorithm describes some kind of a control structure. And we are assuming that the algorithm will be executed by some kind of a mindless robot processor, which knows how to perform simple calculations, summation, subtraction, division, multiplication has some idea about logical operations, can compare numbers, such things, but doesn't understand the idea of the algorithm. So we have to tell this robot what to do at each step. And it's very important to perform this step in exactly that order in which are given. So an algorithm is some kind of a sequence of commands. We are assuming that each command is executed when the previous command ends. Sometimes we would like to change the execution order using conditionals. If something happens, do this, else do that. And this is, very simple control structure. The most common situation is when we are taking one action, and when the action ends, we are taking another action and another action and another action. This is called sometimes direct sequencing. In every semicolon in computer language, period in receipt divides one action from another. Sometimes there is something which is called conditional branching. If some condition, then do A, otherwise do B. Or just simply if Q, then do A. Where Q is some condition, the answer for this condition can be only yes or no, true or false, or something like this. Reheat, but sometimes it's written like this: reheat slightly to melt chocolate if necessary. Necessary or not. Serve with whipped cream if desired. Desired or not. These are conditions. Another control structure is iteration, when we have to repeat some actions. And sometimes it will be do A exactly n times, n is a number, or conditional iteration, sometimes called unbounded iteration, in the form repeat A until Q is true, or while Q means Q is true, do A. Q is some kind of a condition. Beat egg whites until foam. That was taken from the receipt. Iterations can be nested, so this makes the algorithms sometimes quite complicated. Once again, this is an example of a simple program in Google Blockly describing how to compute the factorial. Factorial is, as you know, this is n factorial, so it's enough to repeat n times when E goes through values of starting with value of 1. and starting with value of f equal to not 0. Sorry, what I'm drawing here. This is bounded n times. You have to multiply f by I, changing each time I by 1. And this idea was described here with some older version of block. Nested iterations. This is taken from the maze. Repeat forever. This is the outer iteration until the end. And something like this. Repeat while wall ahead. So there's a situation that in maze, sorry, something like this. The pegman looks at that point. So if the wall is ahead, turn left. There is no wall. And if the pegman looks at that point, there is wall ahead, turn left. There is wall ahead, turn left. There is no wall, and he can go further. This is the idea of this operation. Sometimes, very often, written in a natural language algorithms, we are using such a thing like go to the step number 3 or go to the step number 1, like in the Euclidean algorithm. This many researchers are opposed to using gotos in algorithms, and some programming languages that don't have such a command, but there's quite a lot of programming languages having this command, and this is very useful, especially in natural language. Go back to the step number or something like that. Another idea is subroutine. If you remember the example with turtle, when I provide a subroutine for drawing a circle, special block, draw a circle, and quite complicated, or well, not so quite complicated, several blocks. There is a loop inside allowing to draw a circle by combining 36 steps, if I remember correctly. This is called subroutine. And sometimes is called function. And this is the case in Blockly games. Another example of building the subroutine, let's think about long text, and we are trying to analyze this text and tell how often author uses word money in the sentence. We are not interested in counting number of word money in the text, but we are interested in counting the number of sentences when the word money is mentioned. So the algorithm starts with searching for the first occurrence of word money. When we find the word, we can silently move to the end of the sentence. And for this simple situation, we will assume that each sentence ends with a period and space. When the end of sentence is found, the algorithm adds 1 to a counter, which was initialized to 0 at the start. And algorithm now resumes in searching for word money. So when he found the word money, starts searching for a sequence of characters, not a word exactly, but sequence of characters, dot, period, stop, full stop, and space. And look, this is beginning of our algorithm. We are initializing the counter and searching for a money, reading the characters from the text and comparing with word money. If not found, we are moving pointer through the text, going on, and searching for letters M, O, N, E, R, Y. When we found this word, we are starting for searching of symbol dot space. If yes, we increase the counter and go to the beginning. But look, this part of a procedure is exactly the same in here and in here. But here we are looking for word money, and here we are looking for sequence of letter signs of characters. Dot. So we can draw our algorithm that way. Initialize the counters, search for word money. When you have found the word, search for word, let's say it's word dot space, increase counter, and repeat this situation. But look, this part is repeated 2 times in the original algorithm. This allows to simplify the algorithm using functions or subroutines. Each algorithm uses kind of variables. When I try to compute factorial, where is the factorial? Here, I was using such a f factorial, current number y, I, yes, use these variables. Variable is not a number, not a word, or some other item of data. It's a simple place which can be treated as a small box, cell, in which a single item can be kept for some time. Algorithm utilize variables. With each variable should has his own name for different purposes, but in general they are used for storing or memorizing some values. New value put it into the variable erases the previous content. So when I write this, f put 1 into f here, something like this. Previous version value stored in f, if any, is deleted. taking a value from the variable does not change its content. Each variable can contain only one value at a time. Notation is very similar to mathematical, but we are using different operators. This can be equal sign or colon equal sign or left arrow. In different languages, this is quite different. Let's think about the example of employee list. And to sum all salaries of all employees, I should use sum equal to 0, and I will start sum into sum, put sum, current sum, plus salary of employee, well, in short, 1. Next step will be sum plus salary of employee number 2. Employee number n. And it's much better than using of employees that way, or using employees' names, for example, which also can work. But the algorithm became very lengthy. It's better to make one variable, which will be called, for example, E, whatever. And on the first place is salary of the first employee. That's on the second place, the second employee, third, and employee. Something like this. This is so-called compound variable. And I can got value from this part of using some kind of an index. This is index 1, index 2, 3, index n. And this will be much easier to write instead of days. So and change E at each step, starting from I equal to 1, sum equal to 0. This simplifies the algorithm itself. Sometimes instead of using tables, we are using lists, and well, it's very difficult to say which is better. But in case of tables, arrays, we can use well-known from math structures like one-dimensional, two-dimensional table. This is not possible easily with the same result with list. We have to use compound list, and it's much more complicated. Once again, there is a mathematical notation. We find this one in the subscript 1, subscript 2, subscript 5, or in programmistic notation, v of 1, v of 2, and so on, so on. This is very simple algorithm using vectors. Starting, we have a vector of length n, and we are starting with x equal to 1, and while x is less than n, we will do the following. If phi at x plus 1 is less than phi at x, then we exchange the values. What is in v of x will be put it into v of x plus 1. A previous version of value from vx plus 1 will be taken to v of x. And it will increase the x. Well, you can guess what the algorithm do by computing using pen and pencil. Multidimensional arrays are taken from the math, and the simplest way is two-dimensional array when we have to use two indexes to get value from the value number of the row and number of the column, written that way, like in here in square brackets, or in round brackets, like here, or even like this, from the fifth row, take the third column, the third value. This is the mathematical notation with subscripts, and algorithmic programmistic notation using round brackets. And when we start talking about the arrays, we can think about programmistic structure. Simple data structure is a box for storing the value of x, yeah? And we simply use one instruction to change the value. For example, like in here, put value 0 to x. When we have compound structure vector, to change the values, put zeros in each place, we have to use such a structure, programming structure, and we will have in here y of I, put 0, and change I, and check if and. When we have an array, two-dimensional vector, we should have use nested iteration, and in here there will be something like this. Sorry. And first change I by 1. And check if I is less than number of rows is m, and number of columns is less than n. Sorry. Another data structure is Q. I was talking about Qs a little bit when I was mentioning the stack. The structure is called FIFO, first in, first out. Who first in queue will be first served, who last in queue have to wait for service. And there is a structure somehow similar to the vector stack, and I can put things on the stack, push on the stack, and pop taken from the stack You can think about the stack of plates, something like this. You cannot take the plate from inside the stack. Another one is tree or hierarchy. Very important structure in some situation. This is some example. In genealogy is very often used for displaying the history of people. There are also lists, databases, graphs, somehow similar to trees, databases, somehow similar to arrays, lists, somehow similar to vectors, something like this. And we still have some time, so some digression excursus, selecting the highest person once again. Height of all people are saved in an array called age. This should be height, but it takes up too much letters, too much space. So I'm using the array called age. Variable n contains the number of persons in the room. Other words, is the length of array age. Variable max contains the maximum value from array age when the algorithm ends. Height of the highest person in the room. I is some kind of an auxiliary variable. You should remember that the algorithm described a little bit earlier. Take first person from the class means put it near the door. Take the value from the first element of age and put it into the variable max. Variable a gets value 1. If I less than n, variable I is less than n, all people checked. If yes, if not, I mean I is equal to n or greater than n, output max, end of algorithm. If yes, take another person. This means increase the value of variable I, and check if at the new place of variable age, value is greater than max. If no, take next person. If yes, exchange the value. Put the next value from table H into the max and go to the. And this is, this allows you to produce a computer program using some computer language. Another excursus, quite simple. While x is not equal to 1, do x into x, put old value of x minus 2. And stop. Very simple algorithm, and if we start with negative value, the next value will be -5, -7, -9. Algorithm never ends. When we start with positive odd value, for example, 7, next value 5, next value 3, next value 1. So algorithm stops. When we start with odd, yes, odd, with even 6. Next value will be 4, next value will be 2, next value will be 0, -2, -4. Our process never stops. Easy. Stupid, but easy. Look at this. Almost the same. If x is even, put x divided by 2. Otherwise, x is odd, put into x multiplied by 3 plus 1. Well, this will gives us even value. Because 3 times even will give even. Even plus 1 will give, sorry. If x is odd, 3 multiplied by x will give us odd value. Odd value plus 1 will give us even. So, how does this behave? Starting from 7, algorithm ends with 1. Starting with 3, look, next step will be 3 multiplied by 3 plus 1, 10. 10 multiplied by 2 will give us 5. 5 is odd, so we'll got 16. Next we'll got 8. We will got still even 4, still even 2, still even 1. Algorithm stops. Look at here. This sequence is exactly the same like in here. But think about some very high value of x. How does it end? This is called Collatz problem, and there is something which is called Collatz conjecture that tells us that this algorithm always ends with value of 1. But no one can prove this conjecture. Regardless of which positive integer is chosen initially. But let's go to the beginning. Sorry, I have the simplest way to go through all the slides. This is some graph describing behavior of this problem starting from various values from 166 ends with 1, from 24 ends with 1, but you know, no one can prove this, that it's true. And think. This is so simple. So simple problem. So simple problem. No one can prove how this will behave. And this is the good point to end the lecture. And let's try to repeat once again the poll. 24 persons. Nice. Most of them are sleeping. But well, I think that we can meet in next time, and I will prepare short quiz test which will be performed on ePortal. So please be ready to log in into a portal And this quiz will not be very sophisticated. No, what I'm talking about? What kind of quiz? No. Sorry. I have started today at 7:30 and I really overslept. So I was in a hurry and everything messed in my mind. Not any kind of a quiz. There will be final presentations started from 13th of January, and to this time I will make another two or three lectures for you. 3 lectures, I think. 3 regular lectures. One of the last lectures will tell something about making presentations, so you can. And sorry, I'm really not ready for class for today. The results are exactly the same in general. Yeah, I'm not listening to the lecture. I have to live with that. So, do you have any questions? No quiz, please.
No, thank you.
If not, thank you very much. Bye.
Thank you.
Bye bye. Have a good day.